Good morning, class. I see 12 people have logged in.
Good morning.
Good morning.
Hey, sir,
Good morning.
I have a question.
What you got?
For my assignment for I think the week assignment one.
Yeah.
So the code I wrote, so it was a triple space, right? So I think I triple space that. Can I reassign
Resubmit it?
resubmit it the assignment to triple space? Right?
Well, it was the assignment was supposed what I said was supposed to be double space or triple space.
Triple space. It was
Triple space.
triple space.
Oh, well, I need to go back and grade it because I graded it last night and I graded it to double space, and it should be.
I asked you yesterday, and you said it could be in a sentence, and I got it wrong too.
Right, it's supposed to be triple. Because if that's the instruction, let's look at it. I think I have my screen share. Yeah, okay. Yeah,
it does the triple.
Oh, okay, well, yeah, triples. Yeah. If you research, triple space is leaving two spaces in between. So in actuality, you would have three returns at the end of the output, like the name, inline, the address, inline.
Could we go over that, Professor?
All right.
How to do it right? Because I thought I had done it right, but I messed it up.
Well, like I said, I need to go back and grade it, but I'm gonna show you. I'll go open up Visual.
Yeah, I was curious as well because
right.
Same thing, but
right, but like I'm telling you, what I did, I graded it as if it was to be double spaced. But I'm gonna go back because I remember I did it last night. And because normally what I do is every semester I'll change it to a certain spacing, just to change it up. But I forgot that it was triple space. And triple space, come on up if it comes up. Come on. Shouldn't take that long. Shouldn't take that long. Come on. Okay. All right. What I'll do, I'll just take this out of here. Okay. All right. So if I was to output something like I'll say see out Baton, and I'll say Baton Rouge. And if I wanted to triple space, there's several things I can do, but I'll just do that on see out community. All right, and we had three of them, but I'll just use two. I'll just do something else. Okay. All right. So if I would output this, it would output everything what on one line with no spaces in it. With no spaces, be Baton community with E and the C together, and college and computer science with the E and the C together. So if I can either do \n, and I put community college on the next line, \n, that would leave one space in between them. \n, that would leave two spaces in between them. So all I would need to do is this. Okay, so that's triple space. So let's run it. But I could have done the double quotes and then stream, inline, stream, inline, stream, inline. Either one. It did not matter. So if I build it, I compile it first, debug it. Okay, and let's control F5. All right, you would see that the output would be this. This would the output would produce. Okay, you had Baton, then you had new line, which takes you here. New line, which takes you right above this one. New line, which takes you here. So you have two spaces in between each line. All right, so that's triple space. Double space would have been only two of them. All right, so I got new line, I went to a new line, but then go to another new line. That would leave only one space in between the each line. So see here, that's double space. Print this, go here, okay, then go here. So I got one space in between, one space in between. So that's why I was telling you, look up, if you didn't know what double space was or triple space was, make sure you research it and understand what it meant to double space or triple space, or really triple space. Now, if you did it like this, then what you did was single space. All right, all you did was put one line after each one. So if I run it this way, it's just gonna be one Baton Rouge Community College Computer Science. See, 1, 2, 3, each one on a new line. Now, and then if you try to output it, just output the first one, output the second, output the third, what's going to happen, everything going to be all on one line. And I'll show you what some people did. All right, so you see you got Baton Rouge and the C and the E, community and computer college, computer science, see the C and the E. See, that's what you're going to get. Also, what some people did was this. That what you're doing here is all you're doing is triple spacing in the code, in the source code. But remember, we said all these white spaces here, these lines here, that doesn't mean anything, right? Doesn't mean anything. So if I said, okay, I'm gonna just put each one a new line, \n, and I'll go to the next one, \n, and then I'll go to this one, \n. All right, what it's going to do is going to execute this and print out Baton, go to a new line. All this space here, it will just ignore it. Get to the next command, I'll put this, new line, then skip this space, all this space here, I'll put this, computer science. So you're going to have each one on a new line, all right? So if I run this, see? It doesn't matter how many blank spaces you have in between the commands, you know. So that's what the output. The output was determined by how many inlines you put. Any questions?
So in the future, like if we're doing something like this and you ask for it to be triple space, that last line, like right after community science.
Right. I'm talking about like after here, at the end of here.
Yeah, like after computer science, would you require us to put the spaces after that third line as well, or?
Nuh-uh. See, because that's the end of the output.
Yeah.
You know, it's like, how would I say it? If you how would I say? Say you was printing out a document. Well, say you was a company and you had to print out a letterhead, right? And the letterhead said the address had to be singles or take triple space. You know, if it's just a letterhead, anything after the address, if you don't have anything after the address, it doesn't matter, right? So it's gonna print everything you ask, and that last line it really doesn't matter.
Yeah, because
Right.
in
Right.
mine, like I triple spaced everything. I didn't do it quite like you did it, but I managed to make it
Yeah,
work.
you use inline, okay.
Yeah, I did inline.
Right, but remember what I said? I graded on the basis of it being double space. So I need to go back and regrade it. All right?
Yeah.
Right, okay. Any other questions? All right.
Oh, wait, I have a question. I was trying to find the commands for the command thing, and I was having trouble finding any commands. Like when I only found 10.
Same here. I only had half.
Yeah, I only had half. We could, and the other stuff, and the other ones were not commands.
Right.
They were like what commands list.
Right. Why? Okay. Again.
I don't just like. Can you show where you found your commands? Because I don't understand where you can find them.
All right. All you had to do was C++ keywords. You know, you do keywords. All you can do command. And if you.
But you also passed the definition. I didn't, and we didn't.
Right, but I'm saying if you click on it, you understand?
Oh, but it couldn't. Okay.
You understand? So it's like you got to. I'm not saying you can't just. Oh, I went to that page. That's all it gave. You know.
No. I went to several pages. I didn't go to
Same
one.
here.
I went to like 15.
Okay.
I went to 15 and I couldn't find. It'd be better. I thought it was gonna be some more, and I didn't find a command. I went to 15 pages. I didn't go to one. I went to 15. I do not just go to one and just give up after that.
Right. Okay.
I went to 15, and I didn't know you wanted to. Because it said commands, and when I would look at the page, it said command here. That's why I like, okay, this is showing me something command.
Right. No. Because see, in a sense, how would I say it? Because some people did that too. What they did, they gave me statements. You know what I'm saying?
Yeah, but in the
right, and that's not I didn't want any kind of statement. I wanted.
But in the definition, it said command. I was confused the way.
Right.
Yeah.
Right.
That's what I accidentally did. I used some of the statements instead of the commands.
Right. Yeah. But that's it. Or and I think there's another way.
Can you send a link to us so we can understand, so we see where you got the links to it?
Send you what?
Can you put that link where you got the commands?
Okay.
Somewhere in the Moodle.
All right. Let me. Okay, that's the page. That's one of the pages. Copy this. Well, you want to put it in the chat or what?
Yeah, sure. Can we put a chat? Thank you.
If I could find the chat, let me go ahead. Me and this. There we go. There we go. Okay. Okay, so that's the link. All right. So I posted that one. All right. Any other questions? Okay. Go here. All right. So we kind of stopped on the flow charts. All right. Stopped on flow charting. An example, I could have told you to flow chart your program. If you would have flow charted your program, well, where is it? Because I think we had it in here. if you would have flow charted your program is the one we had with this one. It was similar to this. This is what your program would have somewhat looked like. I mean, your flow chart. Start, display, or output, your name. Output, your semester, your semester, and year. Output, your major. So, and then end. So this is what the flow chart would have looked like for the programs that you would have done. Just what? C out, which is output, C out, which is output, C out, which is output. All right? Everybody kind of understand that logic of a flow chart. All right? It just shows you exactly what is to be done. And we talked about sequential variables and input. All right, so I think we stopped somewhere here, and we were looking at data being inputted. So to continue, let's say variables. A variable, and as we said, a variable is something that's used so that data can be stored in it. Give an example. We said a variable must have a data type, a name, and it can be given a value, okay? And in this example, we could say int, which is a data type, integer, number, which would be the variable name, and we don't have to, we could just say number. We allocated memory and space in the computer for a variable called number of integer so that we can use the variable number. That's a variable. We could even have a variable float, okay? And we could say amount. All of a sudden now we have a variable called amount, and it can hold data of decimals, okay? Decimal point of values, all right? So there's different types of variables. You got numeric variables, which can be of integer or float, but then you got character variables, which say char, and I could say letter. Now we have a variable called letter, and it's of char data type, okay? So a variable would be a name reference, used in the program that where memory is allocated so that you can store a particular value in that memory location. All right. Now, once you have a variable, then you can use your statements in your program to do something with it. Example, I could say number is equal to 5. See, so now I can assign the number 5 to number. So I've already told the computer, create some space somewhere in memory, all right, where I can reference it by using the name number, okay? And it can only hold integer values. So in here, once I get to this statement, it says, okay, use that number space that's allocated and put the number 5 into it. Okay, so that's what's happening. All right, so variables. Okay, variables, you use variables and normally variables can be known or variable values, and variables can be unknown values. Because look here, number, we don't know what number is at this point, but at this point now we know that number is equal to 5. And then what? If it's not a constant variable, it can change as the program goes on, but we'll talk about that. All right, so let's look back at the program. So it tells us, not the program, but the notes. So it tells us quite often a program needs to store data in the computer's memory. Okay, we're using variables. So it can perform operations on that data. For example, consider the typical line shopping experience or online shopping experience. The browser in the website, you browse the website and add an item to that you want to purchase to your shopping cart. So what happens is, as you add those items have to be referenced some kind of way. So some type of variable is created so that it'll know to add this item, this item, this item, and this item. So as you add items to the shopping cart, data about those items is stored in memory. Then when you click checkout, the checkout button, a program running on the website. A computer calculates the total of all items you have in your shopping cart. Okay, so that's what happens. Calculate taxes, calculate discount, shipping costs, etc. All right. Program uses use variables to store data in memory. A variable is a storage location, so it allocates a storage location in memory, right? That can be referenced in memory that is represented by that name. For example, a program that calculates the sales tax of a purchase might use a variable named tax. Now, does it have to be called tax? No. Let's say if I gave everybody the same program to write, where you calculating the tax of a purchase, some people might call it T, which is a valid variable name. Some people might call it tax. Some people make that variable name I'm talking about, and some people might call it TX. Some people might call it taxes. It doesn't matter as long as you're consistent in your program in using that variable name. Okay, so that's what variables are. All right. So if we look here, what they did was they had a sample program where they inputted number of hours a person worked, and then they I think they also inputted I think we went over that, the hours worked and the rate of pay. So they put that information in, it's calculated, and it's outputted. But let's look at this program here where it asks your age, but then do an input, okay, for the age. And it says display the value of, here's the value you inputted. So it just inputted one thing and didn't do a calculation. So we go back here, this program here, and I could take these out. These are different variables. I got int number, then number equal 5. And then I could say C out, and I could put backslash in if I want, and I'll say the number, okay. Now, we know that anything in these double quotes from the C out will be outputted to the screen. So we're going to stream new line, the value of number, which we reference, we telling it number is our variable name here, and then we can stream number, okay? So number here would be within the string, okay? That's just the text, NUMBR. Number here is the actual variable that we assign 5 to equal to. So the output here would be new line, the value of number is, and then this would be 5. All right. So if I run this program, okay, I run it. See, so a new line, the value of number is, and it printed out what? 5. Okay, everybody can see that. Now, check this out. If I would do something like this, who could tell me what happens? Let me open this wider. Can anybody tell me what would happen with this particular statement?
It would put actual word number in the statement instead of 5.
Yeah.
It would put what?
Word number.
Right, it would put number. It would write the value of number is number. All right, everybody understand that? Because when we put the double quotes around the number, we saying it's a string that to be outputted, which is NUMBER. So when I debug it, when I run it this time, it's the value of number is, and I'm saying what? Print out that string, right? So that's different from just printing out what number is. Now, you say, well, Mr. Sylvester, if I'm using int, do I have to use a variable number? No, you do not. Okay, what I'm gonna take this off and make it back to what it was. All right, so now, some student might say, well, number is too long, I'll just use num. But if I use num at this point to allocate the space to store the number 5, well, allocate space. When I want to store the number 5 in num, I have to use the what? The same variable name, which has the memory location. Everybody understand that? And then when I want to output the value from that memory location, I have to use the same variable that reference that location. Everybody understand that? So that's why you have to be consistent with your variable name when you're using it within a program. Because watch this. How would I do it? Yeah, I'll do it like this. I'll set this equal to 0. All right. So we allocated space where number was equal to 0. Num is equal to 0. Then I'll create a variable called number. All right. But then I'll assign 5 to number. These are 2 valid variables, NUM allocated, and it has a value of 0. Number is just allocated, but then I'll assign a number of 5 to it. But then I'm telling it to print out num. All right, what will output here?
A 0.
Right. No matter what my title here says, the value of number. That's on the programmer's part. I have when I'm writing the code, I have to know what I want to output and label it correct. Because what? Even though I run this program, okay, even though I run this program and I keep getting 0, the value of number is 0, and I look here, number is 5, that's a programmer error. That's a logical error. It's not an error within the computer. It's something dealing with me and what I'm doing. So it says the value of number is, and then I got num. So wait a minute, num and number. Oh, wait, this should be number. Everybody understand that? So now when I run it, see, the value of number is 5. Okay, so you can have many different variables in the program. You as the programmer need to keep track of which one you're referencing, which one you're outputting, what label you're going to put to output and let the user see, what that representation is. All right, so you have to do a lot of thinking as a programmer to make sure everything stays in line as to what is to be printed. Okay. Now, you might say, well, what you mean, Mr. Levesque? Okay, I'll give you an example. So if I did something like this, int age is equal to, I'll say 20, okay? And I'll say, give me another integer variable. I'll say, I'll just say items. Items is equal to 5. And I'll do one more, int, something like, I'll just say cars is equal to 10, right? So you as a programmer, you declare and initialize all these variables. Age is 20, items is 5, cars is 10. Now, I'm gonna take this one out because numbers, we don't have that as a variable in this program anymore. So when I go to my cout statement, and I say, I'm in control as to what I'm outputting. So I can say, I'll say your age is, now, if I go here and say items, you understand? I should not get an error, but what? Logically, what? My program will print what? Class, my program's going to print what?
5 instead of the 20.
Yeah, it's going to print, my data not going to be represented correctly, right? And then I could put, And I'll say, and I'll put here, yeah. And then on the last one, cars, I put what I use. Okay. All right. So now, so I have this. Oh, I need to stream this. So I have this information here, right? So what I'm gonna do, I'm gonna run it, all right? And we'll do debug, we'll run it. Oh, it's down here. So when we look at this, we got output, right? And just looking at the output, well, I messed up at the end too. I don't like that. I like to put that space here. And I want you to always do that too. Make sure your data is set where it's readable. All right, so now we have this output, okay? So now, just looking at the output, I have output, it got to be correct. But if we go back and look at our program, age is equal to 20. But look, your age is 5. As the programmer, you have to make sure you're consistent in relating your labels with your variables. Otherwise, your program will represent the data in an incorrect manner. So I'm saying you're doing a lot of different, you're not just writing something to get a completed program. You're writing the code to get your output, but then you have to test and check your output to make sure it is working in the manner that it should. All right. So look here. You have 20 items, but items is equal to what? 5. All right. Int cars equal 10. You have 10. It should be cars. My fault. I should have put cars in, but I put age. But still, it's, and that's another miss. All right. Now, so it's the same thing. So I'll do that. All right. So we have this. So tell me how we can fix this. How can this be fixed, class? How can I fix this code to make sure my data is represented in this example? What would I need?
Change items to
in line 11.
Yes. Oh, in line 11. Oh yeah. Change items to age.
Okay. And in line 12.
Line 12, instead of items, it would be age.
Okay.
No, that stays right. I'm sorry. That stays right.
What? No, because you have age items.
Oh, then age has to change, correct?
Well, we printed the age at the top, remember?
Okay.
So now we want to print out items and cars. So how would I change this for items?
You print, not print, but you would change the age to items.
Correct. Just change age to item and it would say you have items, right? Because if I change age to items here, then it would put the 5 here, right?
Correct.
And then how would I change the last one?
Oh, that stays right. That's right, right?
The last one is correct.
That's correct.
Oh yeah, the last one is correct, right? Okay, the last one is correct. So let's do that. Well, what you all had mentioned. So we change this to age, all right, and then we change this to items, all right. So now let's run our program, and now we get your age is 20. You have 5 items, 5. You have 10 cars, 10. So you understand, sometimes, it's just sometimes you may reference something, or your label might not be just so that your data is what misrepresented in your output. Okay, so you as the programmer have to control that. And many times, like when you work with a corporation, you have teams, and so you and your team will, work on how the output should look, what those variables are, and whatnot, and get that done. And then you'll pass that on to the programming side, and they're working on the same thing you're working on. But when it meshed together, everything should work because everybody working from the same pattern. All right. Any questions? So we looked at variables, and then we looked at how those variables can be given values or whatnot. Now, this is one way a program can be written, where it has what? Known values. A variable has known values. But I can remove this. Okay. Well, now is all I'm doing is allocating a space. I'm not putting a value. So if I run the program now, it won't give me any values in those spaces. They're unknown. All right. So you got an error. So it's unknown. If I would have ran this in online GDB, it would have put 0, 0, 0. All right. That's just online GDB. But now, how would I allow the user, or write this code to allow the user to input values for age, items, and cars? Okay. To do that, we can use the cout. We can do cout. Okay, I'll do /t. I'll do /n/t. Please. Please enter your age, all right? Now, that prompt right there, please enter your age, as the programmer, or you can change that to anything. You could just say enter age. You could say, please enter your age in integer format. Whatever it is you want to tell the user to enter that age. Then, in order for the computer to accept the age, there's another command we're introducing is cn. But notice how the stream goes on the cn. It goes the opposite way of the cout. So I'm going to cn the variable age. So now the computer gonna read in the age, or wait for the user to input an age. All right. So now the next one, cout. Please enter number of items. All right. And then what? cn items. All right. That's the variable. I want to, whatever the user type going to be streamed into that variable. Then cout. If I could tell you. All right. And the number of cars, cn cars. So now, the program does not know what age is, item is, or cars at the beginning of the program. But as we go through the program where we do cout, please enter age, we're retrieving the age, then we're retrieving the item, and then we're retrieving the cars. And then after that, now I can print out the age, the items, and the cars, because what? Values have been assigned. So let's run this program. So I'll go to debug, and I'll run it. And look what happens. Let me scroll down here. Let me scroll this up first. All right. So look what happened. Exactly like I put it. Please enter your age. Now, again, you could have put anything you wanted for the prompt. Also, if I would have misspelled any words in this prompt, it would have been misspelled on the output. Everybody understand that? The computer not going to just say, "Oh well, that word is misspelled," but in this stream here, I'm gonna change it. No, whatever you put in there, the way you put it, it will be out. It be prompted for the user. All right. So here, let's say we put 20. Then it says what? It went to a new line, and then say what? Please enter number of items. All right. Same exact way you got it here. All it did was went to a new line and tabbed over. All right. So I'll say 15. All right. Hit enter. Please enter number of cars. All right. I'll put 2. So when I see the output, look, your age, is 20. You have 15 items. You have 2 cars. All right. Now, so I run it again. The way this program is written, each time you run it, you may get a person may input different values. So if I run it again, now I have the opportunity to put different values in the program. Say age, I'll say 25. All right. Items, I'll say 2. And cars, I'll say 3. See what happens? Now what? Whatever I put in will be what's going to be printed out. Rather than me assigning the values to the variable and I run it all the time, I get the same output. But I'm prompting the user and then outputting the values. Okay? Now, class, we talked about logic, right? We did talk about logic. Now, if you wrote this program, right, and you said, okay, I'm going to write this program and I'm going to take this. I might get an error, but I'm going to show you. I'm going to cut this here. And I'll paste this here. All right. Now, I think I might get error because it's unknown still. So when I run it, but I'm trying to show you the logic. When I run this program, see, I got an error. So what I'm going to do, I'm going to assign this to value 0 equals 0. Because in online GDB, it will work. But in here, you need to have values allocated to that space. So we starting out declaring age, items, and cars as integer and initializing them to 0. All right. So, and we know down here we have where we input the information. But if you look at this particular code, we are outputting the age, items, and cars before we allowing the user to do what? Input the values that they want to input. So what's going to happen? Every time you run the program, it's going to output 0, 0, 0. And then it's going to prompt the user to input age, cars, items, and cars. But it's not going to really use those values because it's going to end the program. So watch. Let's run it. If I do debug, see, age is 0. But then it say, please enter age. So what I did, I outputted the age before, in my logic, I outputted age before I prompted the user to input the age. So say I put 25, 2, and 8. You understand? The program just end. Because what? Logically, the program is not set up correctly. So what? Now I could take this, logically take this out, and place it down here, right? All of a sudden, now what? Initialize to 0. All right, I'm not outputting, but what? Please enter age. So now I'm inputting the age, I'm inputting the item, I'm inputting cars, and then I'm outputting the values. So this one will allow me to prompt for the age and cars and items, and then output the values that was inputted. So if I run this, and I'll put 25, 8, and 2. You see what I'm saying? So logically, or your program has to be in logical order for it to work. So what? The lines of code was correct. They just was what? Out of order. And sometimes when you write code, that could be your problem. It could be logically out of sync rather than something wrong with the syntax of your statements, okay? So all those things have to be considered when writing code, all right? So if we look at this program, Display, what is your age? So what? See out, what is your age? Input age, what would that be? CN age. Then display, here is the value that you entered, okay? And then what? Age. This would be output, see out age. Now, I would want you to put a space in between here, though, for readability purposes. All right. So that's an example of reading data from the keyboard into the computer. But notice here, still everything is just what? Input and output, display, input, display, display. So all these use what? The parallelogram or the input output symbol to what? To actually show or represent your logic, okay, in a flowchart manner. Variable names, and look, these are the rules. Remember we talked about that? Must be one word. If we look at our program here, one word, one word, one word. Okay. I could do this though. Your, if I could type, underscore age. That's one word, meaning what? No spaces in it. That could be valid. But wherever I use it here, I have to use it throughout the program. We got to remember that. All right. Another thing, you can't have any special characters in the name. All right. No special characters. And it cannot begin with a number. All right. Cannot begin with a number. The first character. All right. So those are the rules for naming your variables. And look, it give you an example. Gross pay, that's two words, but they just put them together without the space. Pay rate, put them together without the space. Hot dogs sold today. That's four different words. They just pushed them together to make the variable name where the user could understand. But then what? You could go with this scheme. Gross underscore pay underscore rate. Hot underscore dogs underscore sold underscore today. So it's just up to you. Now here what they use here was they call it a camel case, and they see camel case where you have uppercase and lowercase letters. So look, hot capital D's, dogs sold capital S and T, capital T today. So it just depends on you. Now that's no error. I mean, when there's no right or wrong in this, because what? This is how you develop your programming style. Some students might look at this and say, I'll start writing code this way. Whenever I can do variables, I'm gonna use camel case. Hey, that's part of the programming style. Another programmer might say, well, I'll use underscores. That's your programming style. There's no right or wrong. It's just that's how you choose to write your code. But you got to remember though, sometimes, just sometimes, when you are hired by a company, the company might have certain guidelines. So they might say, well, we don't use camel case in our variable names. We use the underscore. Well, if you want to keep your job, you're gonna have to what? Follow their guidelines, follow their rules. But like I say, other than that, hey, it's just a programmer's preference. All right. Now, we've done this basically, displaying multiple items with one display statement. We just did that, all right? What we did, we outputted this, and here, we outputted this string, and then we outputted an age. All right, so we did that. But we can also output items on in the same thing and cars in the same line also. But we just did the label and the value. All right. So, all right. So here, what they did was they displayed the age, the prompt showing what you entered and then age. But when you look at this example, it says display, here is the value you entered and then what? Age. All right. So all they did was made it one statement rather than two different cout statements. All right. So that's all it's saying. And we did that in the little example we just saw. All right. And look, notice a space. I want you to make sure you remember that space. All right. Because if you don't put that space, that the two will be next to this, which would kind of give it it wouldn't be wrong, but your output would look somewhat confusing. It's not very easy to read. Just put it like that. That's all. It's just not very easy to read. And to add that space, you just put a space after the semicolon before you put your double quote. And that'll allow for a space to be printed. All right? All right. So string input. Right? Now, numbers, int, float, right? Or double. And then now they're talking about string. We didn't talk about char yet. They're talking about string. A string is a series of characters. Your name is a string, okay? The name of your school is a string, all right? So what happens is in a program, in order for you to print or use strings, you would have to do pound include and then string, okay? Now, what you can do here, and what I'll do, I'll take this out, and then I'll say string, if I can type, first name, and let's say string, all right, so string first name, string last name, string birth month. Those are the variables. Those are variables that we're using. Everybody understand that? So now I could say, please enter your, and what? First name, right? But then this would be what? What variable? I cannot say, please enter first name and do CN last name. Now I'm conflicting my prompts with my input. So I have to make sure it match. Right? Right? All right, first name. Then please enter your last name. So obviously, if I say please enter last name, I'm going to prompt for what? Last name. All right? And then please enter your birth month. All right? So birth month. But then now look, now I have to output it in the proper way. Your age is, we're not dealing with age, okay? So I can output this information this way, or I can try to output it in a fashion where I do something like, hello, and then I'll say, comma, and then I'll do first name. Okay, so I'll say hello, first name. All right. And then now I got to try to figure out how I'm going to make it print everything. Okay. How would I do it? And then I could do, see how, trying to make it make sense. Okay. Okay, you enter your name as, okay. Let's see, first name, first name, and then stream. All right, first name and last name, okay. And then I could put in here, okay, you were born in, and then birth month. All right, so all I did was wrote some text to try to match with what we put in on the computer. So now I've inputted that information, and when I run it, it should give me, if I didn't do anything logically wrong, because it didn't say I had any syntax errors. All right. So please enter your first name. All right. I'll say John. If I could type, hit enter, dope. All right. And birth month, I'll say February. All right. Love. Hello, John. You entered. I messed that up. You enter, you should be your name. You enter, and I'm gonna show you. That's what I was telling you too. Well, where's that? Here. See, you enter you name as, and they gonna exactly like you put it, exactly like I have it. You enter you name as. So it did exactly what I put in those double quotes. And you got John and Doe, first name, space, last name. I see that you were born in February. I didn't put no period. All right. So everybody see what happens, how you can manipulate data, input the data, and output the data in a fashion that you want to output it. All right. Any questions about the strings, inputting the data?
I did have a question on the
yes.
on line 24. What's the reason for having to put n9 twice?
I did okay. Let me run it. I'm gonna show you. All it does is separate those last lines that output with the compiler, with the visual compiler. Let's see. I'll put A, B, C. All right. See here, it just moved all this out the way where I can see what my last output was. You understand?
Gotcha.
Rather than putting it right here.
Okay. I was just making sure there wasn't like.
Yeah, that's all. Ain't no big deal. It's just to clear out, kind of like clearing out the space, so I could just focus on just what was outputted. Yeah. That's all. Right. Okay. All right. Any other questions? Questions? All right. So now, what did I do? Here we go. So, okay. So here we got an example program display. Here we would put what? C out, right? C out, then enter your name. Input, which would be CN name. But what will we have at the top of the program? Before we can write this program, we know that name is a string. So we're going to have to what? Load what at the beginning? That preprocessor directory, what? String. Remember in this program here, in order for us to use string, we have to do what? Pound include string. All right. So those are some of the things you're going to, over time, you're going to come to learn. Oh, I'm using string in the program. I have to load the library for string. All right. So display age. Okay. Well, display enter your age. I'll put age. Display hello. And look, basically what we did, hello, whomever, and then the name, and display you are 8 years old. All right. Now, I would allow you to do it, but it might take a little while. Let me see something, because we're pretty close to the, let's see. Yeah, see, this is, no, we got a little bit more. All right, we got maybe one more class period, because I need to go over that. But not, I could go over it, but operators. Right. Operators. All right. Okay. All right, we did the prompt in the user. Okay, class. This is what I want. I want this information. Snippet. I'm gonna do a snippet. All right. What I'm gonna do, class, I'm gonna create a module and make this, I'm gonna make it bonus for you. But I want you to do that. Two bonus. Can I paste? I'm gonna have to come back and put that in. It ain't gonna paste it. Let me save this. Save as. Okay, what I want you to do, class, let's see. Why not showing? All right. Okay, so this is gonna be a bonus assignment. Okay, I don't know descriptions on it. Why did it leave? Why did it leave? What's going on here? Thought I had it. Okay, open that. Okay, it's still. I can't see the bottom of the screen. Okay, so that. All right. All right. All right. So all I want you to do, let's see, yep, make it 10-point bonus. It'll be 10 points, but what I'll do, I'll set it back to 0 once I grade it. All right. So I'll remember. Well, now I could do this. And then I'll make it 0, which means if I give you 10 points, that's as 10 added to 0, which increases increases your average. All right. So I'll give you till Sunday to do that. Okay. Oh, no, submission. All right. So CPP or the text, but hopefully CPP. All right. Save and publish. So what I want you to do, class, given these instructions, right? This is a pseudocode. You should be able to write the code. It's going to be a string, right? Your name is a string. Your age is not a string, right? So you're going to input a name. You're going to input age. Age should be what? Integer. So you need to be able to put those in. But then you're going to output hello, and then whatever you get, comma, well, hello, and then a comma. Well, no, it don't have the comma. Don't worry about the comma. That's just a pseudocode. Hello and your name. And then you're going to output you are, and then stream the age, years old. All right? Any questions about that, class? Questions?
Is there any spacing requirement that you're gonna have for that?
No. If I don't mention it, don't worry about it. And look, that's one of the keys in computer science. When you're given a particular instruction, follow it. If none is given, it's normally open. You understand? It kind of like if I said, or say for instance, my other class, my 194.3 class, I might give them an assignment dealing with floating point, right? With decimal numbers, right? And then we're dealing with dollar amounts. I might say, write this code to calculate whatever, do whatever. Then I might put a note. Please represent all dollar amounts in with 2 decimal places. So all of a sudden now, what? No matter how many, you might have no decimal place, but if you representing $5, you have to represent it as what? 5.00. You got what I'm saying? Or if you have a number that's say 2.8354, you're gonna have to represent it 2.83. You got me? So if it's not specified in my class, you don't worry about it. But if I specify it, then I'm expecting you to keep that in mind and do what I ask. Because sometimes what I do is we focusing on a specific thing, and that's what I want you to focus on. I don't want you to focus on every other little thing. Just focus on doing what I ask you to do. And then as we grow, you'll be like, okay, I know how to do that. I know how to do that. I know that I'm going to focus on that because that's what he asked. It kind of help you. All right. So you don't have to worry about spacing or whatever in this. All right. Now, prompting the user, like I say, we should know how to prompt. When you prompt the user, you should always give them a message as to what to do before you actually read in the data. So what? In our example, you're always going to have a C out telling the user what to do before you have a C in allowing the user to what? Input the values, right? So that's key. If I just had this program and I just had C in first name, C in last name, C in birth year, without these C outs, I wouldn't know what to type. Give you an example. I could go here and comment these lines out. Program is not wrong in the sense that it will execute, but when I run the program, look what happens. So a user executes this program. What are they supposed to type in? They don't know. You understand? So it's like the program is written, but it's not giving the instructions as to what to do. So looking at this, I'm waiting, the computer waiting. So all of a sudden now we thinking what? The program is actually in an infinite loop, which is not. It's just waiting for you to input some. So let me show you. I'll put I'm gonna put some numbers. I'll put 1, 2, 3. So you understand? So it's still prompting me for the proper data, but it's not. It's not a lot prompting to the screen, giving instructions to the user as to what to do. So before you input anything from the keyboard, you should always make sure that you actually prompt the user to tell them what it is they're inputting and how to input it. All right. Now, so that's that part. We don't pretty much went over that. Variable assignments and calculations. All right. We kind of look at assignments, but we didn't look at calculations. All right. When it says a set price equal 20. Remember we did num equal 5 or number equal 5. That's assigning the 5 to numbers. All right. So that's what they're talking about, assigning a value. Now, when I do this, if I do something like this, int, what's wrong? That's not assigning, that's initializing. I'm introducing the variable at the beginning, and at the same time I introduce the variable with the data type, I'm giving it a value. That's called initializing. It has a starting point when I allocate the space. All right, when I do this, num equal 5, and then in my program, I'll do num, and then I'll do number equal 5. Now I'm assigning 5 to number because I could also say number is equal to 5 plus 2 times 3. All right. It's going to solve on the left, on the right, and assign to the left. So I'm assigning whatever that expression yields to number, which is what? It's going to do multiplication and division before addition and subtraction. So that's 3 times 2, which is 6 plus 5 is 11. All right. So that's what would happen. It would assign 11 to number. Okay. Now, so the thing you want to know about when we're dealing with assignments here, set $equal equal to 2.75. Looking at this variable called dollars, what data type it should be? what numeric data type should dollars be?
Yeah, integer.
Look, 2.75
Oh man, decimal.
should be what?
Be as a decimal, right?
Right. It should be what? Double or float, remember? Remember the data type for decimal values is double or float. So, and I'm gonna show you why. If I did int numbers, right? So I allocated a what? An integer location for number, right? And then I'll say number is equal to, I will not get an error because 2.75 is a number, correct? Everybody, correct?
Yep.
Yes.
All right, now, this is what the computer gonna do. It's gonna say, okay, number is allocated to be of integer. So now I'm assigning 2.75 to that integer allocated location. What it's gonna do is says, okay, I'll take the integer part and I'll throw away the decimal part. So what happens? Number gonna become equal to what? 2, correct. So watch, I'm gonna take all this out because we've done, or I'll comment it out. I'll do this and that. I just commented a whole line of statements. So if I do this, see out, and I'll do number equal, and then I'll output number. All right, so now I got number, I got it declared. Then I'm assigning 2.75 to it. It's declared to be integer. All right, so now I'm gonna output it, and it should output what? The number what? 2. So when I run it, see what happens? Because only an integer value can be stored in that memory location. Because we told it what? The memory location should be of what data type? Integer. Right. So sometimes you want to do that on purpose because you want a number, but you don't want that decimal point. Sometimes it depends on the situation, what you're planning to do with that number. But then sometimes, say like if you're calculating the area of for dealing with concrete or whatever, and you got different curves and whatever and whatnot to calculate specifically how much you need, you will want to keep those decimal places because what? They add up over time, right? So let's do this. Let's say float. Okay. So float allows me to what? Allocate a storage location that what? Can hold a decimal number, correct? Correct, Clyde?
Yes.
Yeah.
So now when I assign 2.75 to number and I print out number, it should print out what?
2.75.
Correct. So watch when I go here and debug. Everybody see that?
Yes, sir.
Right? It printed 2.75 because the allocated space was designed or set up to hold a floating point value. But if it was in, it would throw away the decimal part and keep only the integer. All right. So those are some of the little tricks in C++ you got to watch out for. All right. You got to watch. So this set, and just like saying having dollar allocated to what? If I do this, if I had you to write this program, how would I declare dollars? What the data type I'd make it?
You float.
Float, correct. So I would say float dollars somewhere up here. Then I would say dollars equal to 2.75. Then display you have whatever dollars in the account. Then what? Dollars equal to 99.95. Then, but now you have this. All right. But if I'd have made that say int dollars, it'll just say you have $2, then you have $99. All right. So, because once you allocate a variable, you can't change it. If I allocate it to be integer, it's going to be integer throughout the program. All right. So, and that's all this telling you. You know what it replaces. And let me give you an example here. We said what? This is a variable. So we set number to 2.75. I'll delete this so it won't be on in your way. All right. All right. Delete that. All right. So we set number equal to 2.75. Then we outputted number. But what I'm gonna do is I'm gonna do this again. I'm gonna take this, copy, and paste. All right. So now, all right. So now look what happens. I set it equal to 2.75. I outputted number. But then later on in the program, it's lines later, I set it equal to 898.75. That's valid because number is a variable. Number can change. I could store different values in that variable. Okay. Now, when I run it, the first time it's going to give me the first number. The second time it's going to give me the second number. See here? Number is equal to 2.75. Number is equal to 898.75. So as a variable, and it's not being constant, it can change. You can change the value at that location, all right, by assigning it to a different value. Okay, so that's a variable. All right. Now, all of a sudden now you see what? This what? Process symbol. So somewhere in the program you allocated a dollar to equal float, all right? But then here set, remember? Dollar equal 2.75. That's process. The system got to process that. Then what? Display this. Then set the dollar amount to equal to this. Anytime you see an equal, no time that's process. So here you got the process symbol, and then what? Then you output the next amount for the account, and then in. So see how the flow chart changed somewhat because you're using what? A process to assign a value. Process to assign the value. Assign it, output. Assign it, output. Okay? All right. Now, mathematics, all right? These are some of the common math operators, all right? These are like the plus, addition for addition, the minus for subtraction, the asterisk for multiplication, the slash, the forward slash for division. Then you got mod, all right? The mod is modulus, all right? What it does, it divides one number into the other number and assigns the remainder. Okay, we'll look at that in a while. And then you got the caret for the exponent, all right? Sometimes it works in certain compilers, sometimes it doesn't. But let's look at the mod. Everybody should know what addition, multiplication, addition, and subtraction does. But the mod, if I gave you, well, I'll write it in the code. If I said I'll make this int, okay, I'll say int number. All right, now. Oh, well, wait, I'll do this and then we could go, class. I'll do this, then we could go. All right, so I'll do int number. Now, then I could do something like this. The modulus, I'll say, see out, I don't even need number. I didn't even need number. But I'll take all this out. All right, then I'll say see out, and I'm gonna stream number. Well, let's see. I don't even need this. Don't worry about that. I'll say 17 modulus. The modulus symbol is a percent sign. Say modulus 5, okay? And then we're gonna go, because I know people got class. All right, so what happens here? it's gonna divide 17 by 5, but it's gonna output the remainder. What is 17? What is the remainder you get when you divide 5 into 17?
Be 2, right?
Correct. So it divides it, but gives you the remainder. So that should give me a result of 2, the remainder. All right. So if I look at this, it should output 2. You see? 2. Now, what if I do this? Modulus 55. What's the remainder? How many times 55 go into 17?
It'll be
0
negative
something.
Right, huh?
It will be negative.
No, you wouldn't get a negative number because you're getting a remainder.
Oh.
Right. So it should give you the 17, which is the remainder. Because you couldn't divide into it. You see what I'm saying?
Okay.
Right. So you 55 going to 17, 0 times. What's left over? 17. You got what I'm saying? So it always gives you the remainder. All right. So because if I do this, I'll do 2 modulus 3. What's the remainder?
1.
2. 2. 3 goes into 2 how many times? 0, right? See if the number, 3 can't go into 2. So it's 0 with 2 remainder. Now, if I do it backwards, if I do it like this, if I do 3 modulus 2, now what? 2 goes into 3 how many times?
1 time.
1 time with how many remainder?
1.
1. So 1 would be the remainder.
Oh, okay.
Right. So you understand that's how the modulus work. And sometimes we use that modulus when we try to do some things like trick math, some things in math. Like sometimes you need to only find out what if to find out if a number is even or odd, right? If you take the number modulus 2 and it's 0, then the number is what? Even. If you take a number modulus 2 and it's not 0, then it's odd. You got me? Like, what's 10 modulus 2? 0. 2 go into 10 5 times, right? With 0 remainder, right? But if I do 11, 2 go into 11 5 times with what? 1 remainder. So I'm saying you could use this little expression to test to see if a number is what? Even or odd, right? Everybody see that?
Yes,
Question?
sir.
All right. So do my little bonus program. And next week we should complete the chapter and we'll take our test on chapter 2. All right. Everybody got that? Hello?
Yes, sir. Yes, sir.
All right. Okay. And I don't know if I have another program for you to work on in chapter 1. Chapter 2. Yeah. Yeah, no. I don't think I have another one. So work on that bonus program, all right? Well, let's see, week 4. This is not week 4 yet, though. Nah, we'll do that during the time you take the test. We'll work on this one. All right, so don't worry about it. Just work on my bonus program, and like I said, we'll do the notes, complete the notes, and then I'll give you assign the test or whatnot. All right?
Yes, sir.
All right.
Yes, sir. Thank you.
Thank
All
you.
right, y'all have a good one.
You as well.
All right.
All right.
A good one, Professor.
All right, you too.
All right. I have another question for you.
What you
Professor.
got? Yeah.
So for the 20 commands and the week 1 assignment, can I resubmit those assignments? Edit those?
Can you resubmit it? I know it'll help you. Can you resubmit it? Can you resubmit it? what I'm gonna do? I'm gonna post. I'll post, and what I'll do. I'm gonna make it available if I do. All right.
Okay.
Right.
Thank you.
But be watching, right? Don't
All
say,
right.
"Oh, Mr. Best." When I post it, and make sure you do it. All right.
All right.
I check announcements every day.
Yeah. Well, but I don't make you wait that. Well, how would I say it? Sometimes I might forget. But yeah, do check, okay? But I ain't gonna do it to say, "Oh, I'm gonna give it to you the last day to do." Oh, now I gotta hurry and do. No, I ain't gonna do that. Yeah, I don't do that. All right. So just look for it.
All right. Thank you. Have a good day.
All
Have a
right,
great
y'all
day,
too.
Professor.
All right. Bye bye.